Howdy, we are LyRec, the future of bad song recommendations. Our goal is to create a content-based recommender which recommends songs purely based on their lyrics. Our two guiding questions were, can we actually do this? And is it a good predictor of user preference? Our first challenge was finding the data. This was actually extremely difficult because a lot of song datasets don't include the lyrics for copyright concerns. And we wanted both the lyrics and user preference data, which basically ensured that we had to use several datasets and combine them in order to get the data we wanted. We used three different datasets, the Big ML dataset, the Million Song dataset, and the Echo Nest Taste dataset. For most of the project, we only used the first dataset, and then once we used the preference stuff at the end, we combined the other two into it. We had to clean the data pretty significantly. A lot of the data was in the wrong encoding. There were a lot of stop words included, which we needed to get rid of for our models to run well. And some of the data was in completely different languages with completely different characters, and all of this had to be kind of removed. Our first thing was the bag of words model. We won't spend too long with this. Everyone knows how the bag of words works. It basically gets a vector with the amount of the number of occurrences of each word in each song. And you can use these to compare to other songs, which worked pretty well. It found good similarities. It was fast to write and the accuracy was all right. But then we wanted to take this a step further. So we used BERT. And BERT stands for Bidirectional Encoder Representations from Transformations. And it's a language model produced by Google, which takes into account word context. So next slide. You may be wondering why word context is important. Consider the two sentences, a panda eats, shoots, and leaves, versus the cowboy eats, shoots, and then leaves. The bag of words would think they're exactly the same, but BERT would be able to differentiate the content and could tell that these were really referring to different things.
So for our website, which basically lets you search for a song and find related songs, or search for text and find related text, we wrote the backend in Python using Fast API. Our front end is with React, and it's hosted on Vercel. Some challenges we had when creating this is that to train the BERT model, it took a long time. So we had to use Google Colab with their GPU instances in order to make that quicker. We initially wanted to compute the similarity matrix, but with 500,000 songs, that took up way too much RAM, around 2,000 gigabytes, which nobody had. So we compute similarity scores on the fly. And on the backend itself, all the data takes about 8 gigabytes of RAM when running the server. So we couldn't really host it on a free cloud provider. So I'm just hosting it from my laptop. So yeah, all that goes to say that hosting a recommender system is pretty difficult. Now let's go on to our demo. Disclaimer, there might be bad words. I don't know. We'll find out. So this is our website, lyric.app, nice domain name. So you can search for a song here. So if I do here, comes Santa Claus, right. In a second now, it should show some search results.
You need comes, not come.
Yeah, it's bits, very. Oh yeah, let's just do Santa. Spelling's not my. Oh yeah, spelling's not my strong suit. It's not a very. There we go. It's not a very complicated search system, so it just sort of matches text, and we get related songs to this. So you can see a bunch of Christmas songs came up with their lyrics. In the top right, you can see the similarity scores for that, and so this is BERT. So yeah, so a bunch of Christmas songs came up. So that's with songs, but I can actually search by text. So just for fun, let's see what happens when we put Cav's bio as a text vector. So I just pasted this from his website, and any day now. All right. Wow, these are the songs that are most similar to Cav's bio. So BERT on the fly encodes this text into a vector, and we find cosine similarities with all the other songs. Let's see if I can find anything kind of interesting here. There's Instagram.
Yeah, make me a playlist out of this, and I would listen to this in a heartbeat.
Yeah, we can make a playlist with that. Yeah, it's not too similar or anything to any of these songs, but yeah, so you can play around with this at lyric.app. It is running on my computer, so please be nice. And we can go on with our presentation.
So some of the fun ones that we found just by playing with the app is that some Christmas songs worked a lot better than others. Jingle Bells had too many versions, for example, between Jingle Bells and Jingle Bell Rock, that they were all just covers. Here Comes Santa Claus worked a lot better because it's copyrighted. And Feliz Navidad involved both Spanish. It had the intersection between Spanish and English Christmas songs, which I thought was really cool. The other interesting bit of analysis is that when you look up a song like Taylor Swift's Never Getting Back Together, it gave you a bunch of country breakup songs, which it's interesting because it seems like the lyrics were somehow encoding or genre and artist kind of information as well.
All right, so the second component of our project was answering the question of, do people actually care about their lyrics, about the lyrics in their songs? So in order to do this, we wanted to compare BERT and Bag of Words to a baseline model using RMSE. So the idea was we can use these models to create predicted matrices. So we can predict both the counts of listens per user, but what we really wanted to do was make it listen agnostic. So there might be some users that are more music junkies. So we want to instead predict the percentage importance that that particular song will be to a given user. So in order to do this, to create a matrix with user rows, song columns, and then entries of those percentages, we had to piece all three of those tables together. So that involved joining on song ID and song title and artist name. A lot of messy panda stuff. So that was fun. And then for BERT and Bag of Words, we created a content-based filtering system. So it's kind of similar, but a little bit different to what we did in class with matrix factorization. So instead of discovering these latent features, oh, can you go back real quick? Oh. Instead of discovering these latent features with MF, we would instead grab the latent features through BERT and Bag of Words. So for Bag of Words, that means the count vector, and BERT would be the features that BERT discovered. And then generate user profiles based off of the weighted averages of those features for a given user. Finally, we can predict by doing that matrix product and yielding a predicted value in each user song entry. And our results were that no, people don't care about lyrics. And it made me very sad because I was really hoping that we would find, that people really care about the messaging of their songs. These were the RMSE values we got. Our baseline was just random data that we generated, and our baseline performed better than both BERT and Bag of Words. I really got my hopes up because our initial tests yielded promising things that, BERT was incredible and people really care about the content, messaging, and lyrics of their songs. But when I think about what I listened to, I realized that that's probably not true. So with that said, we're open for questions.